Welcome back here to some further maths. We're going to try another speed run here. Right, in an attempt to speed things up, based on last time where I had 5 minutes spare, I have set my clock to 1 hour, and with 1 hour done, we will stop and we will mark what we have done. Now, to help me out, I've also got my physical calculator. That will hopefully be a little bit quicker. And let's just see what we can get up to. I think we did 2023 Core Pure 1, so let's just see where this is going to get us. Oh, 2019 Core Pure 2. So let's try and find this. Core Pure 2. 2019, is that a thing? Well, I guess it is. Here it is. Here it is. All right. I can just remove them at that point. Lovely. All right, let's get going. We're going to get rid of these. We've got our timer. We've got a pen. We've got our calculator. We have some tea if we feel that we have the time for some tea. So let's get going. Bomb. Question 1. Inverse tang. Okay. Let's maybe zoom in a little bit. I know we're wasting time already, but still. Right, inverse tang. So y is tang minus 1 of x. Tang. Let's pretend that an examiner is actually having to mark this. Tang y is equal to x. So that's e to the x minus e to the minus y. E to the y, e to the minus y. Over e to the x minus e to the y plus e to the minus y is equal to x. So we're going to times everything up. E to the y times 1 minus x minus 1 plus x. If I'm e to the minus y, I do believe if I bring that up, yep, times everything by e to the y. And divide through. So e to the y is square root of 1 plus x over 1 minus x. So y is ln of square root 1 plus x, 1 minus x. And using the rules of lns, that is 1/2 ln 1 plus x over 1 minus x. Beautiful. Okay. X has to be between minus k and k. So 1 plus x over 1 minus x has to be positive. Isn't that true? So 1 plus x is 0 minus positive 0 minus 0. Positive for 1 minus x, in fact, no. That will be positive 0, negative. So overall, we will be negative 0, positive 0, negative. So we are minus 1 and 1. Right, solve that equation. Well, 2x is no. Okay, we're going to have to connect our tablet. This is wasting time. If I make enough dinosaur noises, that clock is ticking. How was I not ready for this? Right, that should work for me. Tick, 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 people. Tick, 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 tick. Right, so if I rewrite that question, inverse tang of 2x is ln of square root 2 minus 3x. So that is 1/2 ln of 1 plus 2x over 1 minus 2x is, and I'll take that square root out as well on the right hand side. So we end up with 1 plus 2x equals, and I'll multiply it up because we are trying to be quickety-spit-lick. Those are words. 1 plus 2x equals 2 minus 5x plus 6x squared. So we end up with 6x squared minus 7x plus 1 equals 0. That defo works because it's minus 1 minus 1. So I get x is 1/6 and x is 1, and that should be okay. No, that one is not okay. That one is not okay. Now you can see that because if you plug that into there, I get x is 1, but if you plug that in, that would be square root of minus 1, and ln of minus, and that's just no good. So we'll take ln of 1/6, and that looks like that works. So that one is not a solution, as 2 minus 3x would be negative. Sad face, so this is my only solution. That is my final answer. Right. Question 2. Some roots. X cubed minus 2x squared plus 4x minus 5 is 0. So we know, oh, P, Q, and R. Okay, fair enough. P plus Q plus R is 2. PQ plus PR plus QR is 4. And PQR is 5. So we want 2 over P plus 2 over Q plus 2 over R. If we make this a common denominator, that will be 2 times QR plus PR plus PQ over PQR, which is 8 over 5. P minus 4, Q minus 4, R minus 4. Okay, that is PQR minus 4 times PQ plus QR plus PR plus 16 times P plus Q plus R minus 64, unless I'm very much mistaken. So that is 5 minus 16 plus 32 minus 64 minus 32 minus 48 minus 43. We'll come back and check at the end. Oh, I hate this one. I hate this one. I hate it. I hate it. I hate it. Because I never remember the formula. For you boys and girls at home, you should probably just know this formula, if I'm honest with you. So that is P squared plus Q squared plus R squared plus 2 times PQ plus QR plus PR. Now there's a reason for this, right? There's a reason for this. So what did we say? P plus Q, so that is 4 is P squared plus Q squared plus R squared plus 8. Well, that tells me that some of them are negative, but that's okay. Some of them are imaginary, but I'm not going to fret about that right now. And then we're going to do P plus Q plus R times P squared plus Q squared plus R squared, because that will give me a P cubed plus PQ squared plus PR squared plus PQ squared plus, sorry, no, P squared Q plus Q cubed plus QR squared plus P squared R plus Q squared R plus R cubed. Now, the one thing to remember is we are going to add on a PQR, we're going to add on a PQR, and we're going to add on a PQR, which does mean overall we need to remove 3 PQRs. Because I want PQ times something. Because what we're going to do is we're going to group these PQ squared, P squared Q, and PQR. And we're going to group PR those 3, and we're going to group those 3. So P plus Q plus R, we've already said, is 2 times minus 4 is equal to P cubed plus Q cubed plus R cubed. Now, the reason for this is if you look at those, the yellow ones is PQ times P plus Q plus R. That's the yellow ones. And then we got the other ones as well. And you'll see the equivalence. Plus PR times P plus Q plus R. And that will be the blue ones. Right, so what we end up here with is actually P plus Q plus R times PQ plus PR plus PR minus 3 PQR. So minus 8 is P cubed plus Q cubed plus R cubed. And then P plus Q plus R is 2. Double products is 4. Minus 3 times the product is 5. Right. So that's 8 minus 15. 8 minus 15 is minus 7, so minus 1. I'm going to put a little star on that one if we have time at the end, which I don't think we will. Right. How are we doing? Don't know. No time to think. Right, question 3. F of x is 1 over square root 4x squared plus 9. So we're going to have to do this properly with the substitution. Because I also very aggressively did not get my formula sheet out. So I want the substitution 2x is equal to 3 sine u. What is it? Sine squared plus cos squared minus cos squared is equal to 1. So no, I want 3 cos u. I want 3 cos u. Because then this becomes 1 over square root 9 cos squared u plus 9 times 3 over 2 sine u du. Because that becomes 1/2 du, because that's just 9 sine squared, so 3 sine, which becomes u over 2, which is 1/2. Oh no, they've gone for that. Am I insane? It's the other way around. I'm just being a numpty because I'm going fast. Okay. It is cos squared u minus sine squared u. So that is a sine. Silly boy. So that becomes a cos. That becomes a sine squared u. They cancel out, which is 1/2 then sine minus 1 of 2x over 3 plus some constant. Right, B. Find the mean value of f of x over the interval 1 to 3. So we need 1 to 3. Sorry, 0 to 3. So that's the width of the interval. Shine minus 1, 2x over 3, between 0 and 3. That I do know is 0, and we need this as a natural logarithm. Right, let's go get our formula sheet, because at this point, I should just have it saved. Right, there it is. Do it completely. There we go. Arc shine. That is arc shine is ln of 2 plus root 5. Let's go with that. No time to check. We keep moving. How many of you are howling at the screen already? Question 4. Yes. C plus is e to the I theta plus 1/2 e to the I 5 theta plus 1/4 e to the I 9 theta plus ... We are multiplying every time by 1/2 e to the I 4 theta. So this is an infinite series, so it's e to the I theta over 1 minus 1/2 e to the I 4 theta, but we need to tidy this up. Oh no, we need to show, right, times top and bottom by 2. Let's be explicit on that one, times 2 times 2. If only we had nice colors like this in the exam. And part B will be to tidy it up, so I'm going to multiply top and bottom by 2 minus e to the minus I 4 theta. It's going to give me 4e to the I theta minus 2e to the minus I 3 theta. Good, we've got some 3 thetas in there. So what do I get here? I get a 4, I get a plus 1, and I get a minus 2 e to the I 4 theta plus e to the minus I 4 theta. So C plus IS is 4e to the I theta minus 2e to the minus I 3 theta. Now that bottom then becomes 5 minus 4 cos 4 theta, because of course we know that e to the ik theta plus e to the minus ik theta is 2 cos k theta. Write that in my working somewhere. And what do I want? Therefore, S is the imaginary part of that. So that will give me 4 sine theta minus 2 sine, and I'm going to be really explicit here, minus 3 theta over 5 minus 4 cos 4 theta, which is 4 sine theta plus 2 sine 3 theta over the result that we wanted. Okay, no time to check. That was our downfall. Keep going, keep going, keep going. Oh no. Is it oh no if I say that every single time? Engineers investigators. Okay. It's 4 dh dt plus 37h is 0. General solution. All right. 4 lambda squared plus 4 lambda plus 37 equals 0. Well, that feels unpleasant, but there we go. Surely not. 4, 4, and 37. Am I missing something? Come on, calculator. There's no pride at play here. Okay. Lambda is minus 1/2 plus or minus 3i. So we get that h is e to the minus a half t times a cos 3t plus b sine 3t. Okay. Try and make it so that the pen is in fact working. Right, when t equals 0, so h, the vertical displacement above e, so t in 0 is 20 centimeters below, so h is minus 20, and is moving upwards with a speed of 55. So dh dt is 55. We've got the right units. Okay. Dh dt is minus, so let's just differentiate it first. Plus 3e to the minus half t times minus a sine 3t plus b cos 3t. Make sure that minus, because I can see myself forgetting that. So we get minus 20, putting 0, so that's a 1. That's a 1, and that disappears, so is there. Cool. And then 55, let's put t as 0 into here. Gives me minus a half a from this one, plus 3b from this one. So 55 is 10 plus 3b. Well, that is quite exciting. That gives me b is 15. So I get h is e to the minus a half t times minus 20 cos 3t plus b plus 15. And that, yes, I see what we've done here. Plus 15 sine of 3t. Now you just need the maximum vertical displacement. So that is going to be, I can take out 15, that's 4 times 5, 3 times 5, so it's going to be 25 e to the minus a half t. Because that's a minus, I'll write this as a sine of 3t minus alpha. Which I don't need all those brackets, do I? Where tan alpha is equal to hang on, that would be the cos, that would be the sine, so 20 over 15 is 4/3. Okay, so max h equals 25 centimeters. We could have found a maximum by trying to solve that equals to 0 and going through the whole process, but actually, a little bit of harmonic form, we spot a Pythagorean triple, bosh. Meh, as t goes to infinity, h goes to 0, but is never actually 0. In reality, it will stop. And that's what I'm going for. All right, let's go. How are we doing? We're about halfway. I've not kept track of marks. Oh, that looked like they wanted it to be a long question. We'll find out. Argand diagram. Ah. Got an equilateral triangle. One of its points at 6 plus 2i. Something like that, maybe. Doesn't really matter because 6 plus 2i. That's not ideal, but the point is that's 2 pi over 3. So what do I need to do? I need to do 6 plus 2i. So that is point A. That's point B. That's point C. So point B is 6 plus 2i times e to the 2 pi over 3i. Now that is 6 plus 2i times cos 120 is minus a half plus root 3 over 2i, I do believe. So that will be, let's find out. So that will be 3 minus 3, 6 times minus a half, minus root 3, plus 3 root 3 minus 1i. And that's my answer. And then point C, we're going to do that again. So we'll take our minus 3 minus root 3 plus 3 root 3 minus 1i, and we're going to times that again. Do you know what I'm going to do? Do you know what I'm going to do? Because I think this is going to be nicer. I'm going to go 6 plus 2i times minus a half plus root 3 over 2i all squared. 6 plus 2i times, I get a quarter minus 3/4, so that's minus a half. And then I will get, yeah, and then I will get minus root 3 over 2i. Makes perfect sense. So we get minus 3 plus root 3. No, minus 3, not minus root 3. Got 6 marks for this. Minus 1i minus 3 root 3. Again, we'll do a little check on that right at the end if we have time. Points D, E, and F are the midpoints. What are you doing to me? D, E, and F. Oh, okay. All right. Okay. All right. Find the exact area of that triangle. Well, it's 1/4 of the area of the big one. Right. What's the mod of 6 plus 2i? It's square root of 40, isn't it? Which is 2 root 10. So I'm going to do 3 times A, B, sine C, it's going to be 2 pi over 3, over 2. To get the area of the whole triangle. So bomb. That is 10, 20, that is 60 times root 3 over 2. Which is 30 root 3. And then I want 1/4 of that. Because if you have a look at that one there, 1, 2, 3, 4. No time to check. We are going full on speed here. Our score is going to be abysmal. How are we doing? Still got 32 minutes. All right. Find the values for which it has an inverse. So let's find the determinant. So that is 2 times minus k minus 8 minus 1 plus minus 3 minus 12 minus 6 minus 3k. Now that determinant needs to be positive. Minus 2k plus 3k, so that's k minus 16 minus 15 minus 6 is positive. So k has to be bigger than 37. Don't like that. Okay, I'm going to take a precious. How much more paper do I have? I've got question 7. There's an 8, and that's it. All right. Okay. All right. 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 No doubt. No doubt. No doubt. No doubt. So, okay. So if I go 3 by 3 and I go 2 minus 1, 1, 3, let's, right, 2 minus 1, 1, 3, 38, 4, 3, 2, minus 1. Let's go det mat A. That gives me that. And what if I turn that to 36? It's minus 205. So that is not right. Okay, so good job I checked that. So let's do that again. Minus k minus 8. According to me, if k is less than 37, I should get a negative determinant. I wrote this down wrong. What is wrong with me? What is even wrong with me? Why do I find these so tricky? 2 times that. If I do it the other way around, I get 2 times minus k minus 8 minus 3 times 1 minus 2 plus 3 times minus 4 minus k. That's got to be positive. Yeah, that's minus 5k. Because that's a plus. There we go. Just doing it on a different line. Yeah. There we go. Yeah. 5k. K is bigger than 37 over 5. What's 37 over 5? 7.4. Okay. And if I go 7, that also works. What is actually wrong with me? Oh, because that's a plus 6. Ah, come on. Stop trying to be fancy. Stop trying to be fancy. K bigger than 5, is it? Watch me have a meltdown live. K should be bigger than. Let's do it. All right, I threaten you. That's minus 5k, obviously, because that's minus 5k. So is it k has to be less than 5? There you go. We felt safe, and then this happened. Same as last time. Right, minus 5k is greater than 25. Let's just do this properly. Ugh, 2 marks. I've just absorbed so much time into these 2 marks. K less than minus 5? I'm just being dumb. I'm just being dumb. And you've been watching this for the last, what, 10 minutes? We have a problem when it's 0, not when it's positive, you absolute monkey. So we want k not equal to -5. In theory, -5 is the one that will do an issue for me. Yeah, then I get a det of 0. Right, cool. All right, find in terms of p the coordinate where the following planes intersect. Yeah, funnily enough, that. 2, -1, 1, 3, -6, 4, 3, 2, -1. Times x, y, z is equal to p1, 0. So we need to find the inverse of this bad boy. So m-1 is 1 over, so here we've got k is -6. So my determinant is five. But you know what? They've given me everything I need. I can just do the inverse of the matrix, can't I? Yep. Awesome. Awesome sauce. -2/5, 1/5, 2/5, 3 -1, -1, 24/5, -7/5, -9/5. So my x, y, z is that. Times by p1, 0. Minus 2p plus 1. 15p minus 5. And 24p minus 7p. And one can only expect, I'm just going to do that a quick go. So 2 times minus 2p plus 1 minus 15p minus 5 plus 24p minus 7 equals minus 4p plus 2 minus 15p plus 5 plus 24p minus 7 equals 5p. Cool. And then I need to divide all of that by 5. That seems good to me. So that is my answer. Okay. Find the value of, okay, fine. So now what we have is we are in the case where we have a 0 determinant. So either there is no solution or there are infinite solutions. So for there to be infinite solutions, this needs to be a combination of the other two. So I'm going to say 1 is a times 2 plus b times 3. So if we look at the x's, that means that 2 has to be 3a plus 3b. If we look at the y's, tells me that -1 is minus 5a plus 2b. And if we look at the z's, it's telling me that 1 is equal to 4a minus b. And if we look at the other ones, at the q's, at the constants, it tells me that 1 is a q. Okay, 1 is a over q. So we need this level of consistency. So if we solve these two, And I am just going to go for my simultaneous equation solver on here because I'm running low on time. So -5, 2, -1, 4, -1, 1. A is a third, B is a third. Which works for that one. So there we go. That will keep all of that nice and consistent. A is a third, B and a third if you look at that. So that's telling me, yeah, that equation 1 is 1/3 equation 2 plus 1/3 equation 3. Then the right-hand side needs to be consistent, in which case Q needs to be equal to 3. For this value of Q, interpret the solution. Well, they form a sheaf. So if we solve this, so if we solve either one of these two, we solve these simultaneously, right? We will get the line of intersection. So what should I do? Let's do equation 1 plus equation 3, because that will give me 5x plus y is equal to 1. And then that got rid of the z's, and I want to get rid of the x's. So I'm going to do 2 take away 3, or do it the other way around. 3 take away 2. If I do 3 take away 2, I will end up with 7y minus 5z is minus 3. And what we're going to do is let's just make y the constant. So y is 1 minus 5x, but it's also equal to 5z plus 3 over 7. And we could probably, if I divide everything by 5, I get y over 5 is 1/5 so x over minus 1 over 1 even. That becomes x minus 1/5 over minus 1, and that becomes z plus 3/5 over 7. Okay, so this is the line 1/5 0 minus 3/5 plus lambda minus 1 5 7 is the line of intersection of all three planes. That feels horrible, but again, we are going for speed here. Question 8. Circular horizontal cross section. I gotcha. I gotcha. Could I have used the lines? Of course I could. Was I gonna? No, of course I wasn't. That is y is ln of 3.6x minus k, and that's at the point 1. Is that right? Find the value of k. Well, 3.6 times 1, because that's at x is 1, minus k has to equal to 1, so k is 3.6, I do believe. .6 even. K equals 2.6. Now, according to this, that is 1, so that has to be 1.18. Half of AB. Half of AB, right? Half of AB. So, that there is at 1.18. So we know that the y value there is ln of 3.6 times 1.18 minus 2.6. I mean, whatever it is, right? I mean, 0.500 when we're rounding. 0.500 meters. Did it say exact? Find the depth. No. Find in terms of h, the volume. Right, so we are, of course, what we are going to do here is we are going to do our volume of revolution here up to h. So we're going around the y, so we want pi integral from 0 to h of x squared dy. Oh, you're kidding me. Right, e to the y plus 2.6 is 3.6x. Not impressed. Not impressed. E to the 2y plus 5.2 e to the y plus 2.6 squared dy, which is pi over 3.6 squared e to the 2y over 2 plus 5.2 e to the y plus 2.6 squared y between 0 and h. So we end up with pi over 3.6 squared times e to the 2h over 2 plus 5.2 e to the h plus 2.6 squared lots of h minus 5.7, whatever that comes out to be. I'm not getting caught into this one after last paper where the last one was absolutely horrific. Given that the pool is being filled as a constant rate of 15 litres every minute. Oh, that's maybe not too bad. Okay, so dv by dt is 15 litres. What's that in centimetres cubed? 1 litre is 1,000 centimetres cubed. Per minute. So, which is, we want it in centimeters per hour. Oh, and sure. We want the right. So we want dh dt. It's going to be dh by dv times dv by dt. Right, so we want h is 0.2. Now, dv d8, this is the volume in there, right? It's 3.6 squared times e to the 2h 5.2 e to the h plus 2.6 squared. I'm going to put in h is 0.2. So pi over 3.6 squared times e to the 0.4 plus 5.2 times e to the 0.2 plus 2.6 squared is that, right? 3.54. So this is going to be 1 over 3.54 times 900,000. I mean, 254,244.8 centimeters per hour? Really? Really? And there we are. That is where we are. Are we going to call it there? We got 10 minutes. We're going to stop. We're going to check. Oh, no. Call it. All right, time to mark this bad boy. So let's have a look. Question 1. Where do I get marks? I get a mark here for writing this out. Bit rearranging. E to the 2y is equal to all of that. Then last mark for getting the rearrangement. So cool. So far, so good. 2x x equals tanh. Oh no, we're down here, right? So I get a mark for that. Mark for that rearrangement. Oh no, my quadratic's wrong. Oh no, that's not good. Why? Oh no, it's 2 times minus 2x. Oh, so it's minus 7x on this side. Oh no, because it's 2 times minus 2x. And again, we will put a link underneath. We will happily send you out a PDF with my working. Unpolished, it will have my markings on it, right? The idea is like it's easy to find model answers on the internet, right? You can get model answers, but they're not realistic. All right, they aren't answers that people have produced under pressure. They're answers that people have had time to sit down and redo and relay out and everything, right? These are my raw, unfiltered thoughts as I go through this paper. Might they be of use to you? I don't know, but this is what we're offering you, right? I'm not hiding behind having redone it, having refilmed it. Like, these are my honest mistakes under quite a lot of time pressure for this one. I won't fib, but still, not making excuses, right? So that should be minus 9x. So that's all wrong. And then we'll solve it. I think we get the same ideas. X equals 9 minus root 57 over 2. And the reason for that is 9 plus root 57 over 2 will be bigger than 1. So not valid. So we lost 3 marks for that one. 1, 2, 3. So I get the first 2 method marks, but not 3. So I'm at minus 3 on that one. Ah, that's not good. What's that last bit? Did I miss a bit of the question for question 1? Oh, we're all the way down at question 6 on the paper, apparently. Hence or otherwise. No, I'm not sure what that last bit is referring to. Maybe it's part of way 2. Alternative for first 2 marks would be, okay. So that is 7 out of 10. Sad face for question 1. All right, what a start. What an inauspicious start. So let's have a look. Sum is, okay, I get all of those. Okay, thank goodness that didn't go wrong. We've got that method mark, we get that mark there. Okay, part 2. Expanding it out. Bosh, bosh. Minus 43. Wicked. All right, I'm feeling better. Now, again, this one, either you know how to derive it quite quickly, or quite honestly, like I say, it is possibly worth, it doesn't come up every time, but it is worth knowing this formula. All right, so it's what I rederived over here. It's what I rederived over here-ish. Okay, but you can figure that one out as well as you go along. I think I did something along these lines, but it really is worth just knowing it. Did I get the right answer at the end of the day? -1, yes. All right. And yeah, that's a tick in there. So we get 2 marks there. All right. They clearly do just expect us to know these identities and not rederive them every single time. That is a choice I make by not learning them. To be honest, it's just one of those things. Oh, that's that. So that is 8 marks. What? 1, 2, 3, 4, 5, 6, 7, 8. Cool. 8 marks. 8 out of 8. I'll take that. I'll take that. I wasn't sure there with the negatives, but it just means a couple of them. If you look at some of my sub-construction here, like these are all squares and you get a negative, it does mean we've got a complex conjugate pair in there somewhere. Not that we need to know that. X is 3 over 2 shine u. Got there eventually. Embarrassing. We plug it in there. We get that integral and we get what we need. So 4 marks. Excellent. I mean, we just apply it, right? Bosh, bosh, and that is 6 out of 6. Okay, all right, all right, all right. We're back on track. Can we get into the 90% despite that early fumble? I mean, this one, we just got there, didn't we? So C plus IS, I think that would get me mark number 1. Yeah, I've just written it in EI theta form. I've got that 1/2 e to the I4 theta is probably what we want to be seeing here. Which will get us our last one. I think I get all marks for that. What do they want to see? They want to see that we've turned it into an infinite series, which I do feel like I've done here. Then I've shown what I would think is this second mark there, that we're multiplying 1/2 e to the I4 theta every time. Then I've written it as an infinite here, that one there. Multiply top and bottom by 2. Yeah, I think we're all good there. Look at that. We've multiplied top and bottom by that amount. This one feels a lot less ambiguous. Yeah, I think we're there. 4 marks for part B. That's a total of 8 out of 8. We'll take that. Again, bosh. Lovely. Now, you'll notice that I've got slightly shorter hand notation here. Probably if I wasn't trying to get this done in under an hour, I would have written it out a little bit more like they have done. All right, so do make sure you're writing your working down. But again, in the context of this being a speed challenge and me actually trying to focus on the speed side of it, I think we're doing okay here. Okay, but when you're actually taking a full hour and a half, make sure you're not leaving your work down to any ambiguity. All right, number 5. Lambda is this. Bosh. Well, I used M. Well, I use lambda. I'm a lambda kind of guy. So the first mark is to get A is -20. We get a method mark for differentiating. Then we get a third mark for concluding what H actually is. Oh no. Tan 3t. So they did go about and solve dH dt equals 0. Oh no. Oh no, I forgot about this one. Oh no, so I'm gonna lose what? 3 marks. Ah. Okay, so let's correct our work. I maintain that going to the harmonic form was the right way. So let's go back to this. To make this work, so I forgot this term. That is awful. Right, so let's use my harmonic form, right? Let's just try and backtrack here. So I would need 3t minus alpha equals pi over 2. So t is equal to, and you know what? I will use the old on-screen calc for this one. Is it up there? Yeah. So we said that tan alpha is 4/3. Let's make sure we're in radians. No, I'm in degrees. So let's go into radians. So let's see if we can cut. Arc tan, did I get this bit right? Or should it be 3/4? All right. So we're going to add pi over 2 and divide that by 3. 0.8326 for t. Ah, we disagree on, so they said 22 over 21. So let's just double check this. Sine, that's the cos, that's the sine. What's 20 over 15? 20 over 15, right? Am I being dense? It's 4/3, right? So they reckon t is 0.778 at the maximum. I want 3t minus alpha to be pi over 2, so that I get 1, because I want the maximum. I've got the 25 in front, so is that my issue? Is that my issue? Arc tan 4 over 3. Trying to justify my working here just to make sure I'm not. Arctan of 4 over 3. So if I expand this, I get sine 3t cos alpha. So let's go cos, actually, let's save this as a. So what is cos of a? 0.6 times 25 would give me the 15 that I want. And then you get minus cos 3t sine alpha. Oh, it's just sine a. Give me the 20. So why would that not work? So I want 3t minus alpha pi over 2 plus a. I get 0.8326, you know? 25 times e to the minus a over 2, 15.724. Why am I out? Why does this, like, don't get me wrong, I see why they've done it, right? And I know what I've done a boo-boo on. But having said that, why would my methodology to find the maximum value of h not work? Ah, because maybe it's not quite so simple. Because it's decayed. So maybe I can't do this. Maybe I can't do this. It's not as simple as finding the max oscillation of this and then plugging in the value of t. No, so we've got to solve dh dt equals 0. We've got to solve that. That's why. I tried to be too cute and clever. Hashtag too cute. Ugh, didn't like that. So let's pop that in here so we can do it. That is a big old whoopsie. I did say as I was doing it, but then I tried to be, you know, all betterer than everyone else. So that would be e to the minus half t times minus a half a cos 3t, because we got, oh, well, that's just awful, right? So for the causes, we would get, I think you just need to go through it again. I'm not going to put the whole solution on here, but see the mark scheme, right? Minus a over 2 plus 3b cos 3t. And then for the sines, it would be minus b over 2 plus 3a sine 3t equals 0. And you just need to solve that at that point. Oh. So what's that? Minus a over 2 is 10. What's that? 55 cos 3t. They get tan 3t is minus 22 over 21. Maybe. B over 2 is 7.5 minus 60 minus plus 52.5. So tan 3t is minus 55, 52.5. And just to check my own sanity here, 22 over 21, which is what the mark scheme says. Okay, and then you can go from there. Get t equals, and then plug that back into there. That's a shame. That's a shame. I really thought I was onto something there, but there we go. So how many marks have we lost on that? 4 marks. We've lost 4 marks total. That is a bummer. We've lost 4 marks total on that one. Don't write MERT in your exam. Consider large values of t. When t is large, the value of h is never 0. So there we go. So we get our 2 marks from there, just something sensible. So that's 8 out of 12. So we've lost 8 marks so far. All right. So that is right. Oh, they've put the whole rotation thing, or times by that. Cool. So we get that first method mark here, this line up here. Oh, we don't need you, calculator. Go away. So we get minus 3 minus root 3. Yep. And yep. So they do, yeah, I get those 2 marks there. The answer 1, answer 1. And then for doing the other one, we do it again. Bosh, bosh, bosh. So 6 marks. Nice and simples. Find the area. So 3 times the area of ABC. So that's classic. So that's what we did there. Now the area of DEF is 1/4 of that, which is what we did. And we get the 15 root 3 over 2. Smashing. I'll take that. So how many marks was that one? Oof, they've got lots of different ways to do it. I'm not going to go around it, but they all go around finding multiples of these areas and then doing the quarter, something like that. So that's where you want to go. So that one was 9 out of 9. I'll take it. Lovely. All right, we're into the last couple of questions, I think. Question 7, question 8. Right, det M. Let's not talk too long about how long it took me to get that one. K not equal to 5. That was a bit embarrassing. So we want to see that m minus 1, which we are seeing here. M minus 1. Again, you can just get it from your calculator, so I'm not sure why you would want not do it. Bosh, that first line there. Yeah, I think I've put that there, so there we go. So so hang on, 1, 2, 3 to get to there. Then x, y, z is equal to this. Oh, I didn't write it in coordinates. I wrote the position vector. I wanted to write it as, oh, that feels harsh. That feels harsh. But I suppose I did write a position vector and not coordinates, and it'd say find the coordinates, didn't it? So that is a little bit harsh. Lost a mark there. Ooh, feel hard done by, but you know, it is what it is. So they've gone for consistency. So what did they do? 5x plus y equals 4 minus q. So basically they eliminated instead. So they did that one plus that one. So they did 1 plus 2 and they did 1 plus 3. Sure, for some reason. 1 plus 2. The 1 plus 3. right? And I think they eliminated Z in the other way using 2 and 3, and then they compared them. Sure. All right. Yeah, why not? Yeah, I'll take it. All right, I quite like to do the linear combination thing, but it's a personal idea, but Q is 3 and 3. There might be, yeah, they just did it with a number, and then, oh, are you kidding me? 3 planes that intersect in a line, they form a sheaf. Allow sheaf. Oh, why did I go that far? Why did I do that much working? Which one's this one? Question 7. Why did I do this much working? This is mental. What's wrong with me? Yeah. Oh, so that 4 marks is for C part 1 and part 2. That's why I did so much work. Oh, that's bad. And even worse, I think I don't get the mark because I probably need it again. Look, I will not give me that because that's too brief. So I've lost 2 marks on that question. So that's 9 out of, that's 9 out of 11. I think that's too brief. They definitely want 3 planes that intersect in a line. Oh, well, actually, ooh. See, two idea of planes and meeting in a line. Oh, I just put 3 planes. Well, it is 3 planes, isn't it, basically? Let's be harsh. Let's not give us the mark. I think there is a world where that's okay. Now, this one I know went wrong. This one I know went wrong. I got the working. I'm going to give myself that because I put it to 3 sig fig. That's absolutely fine. Yeah, working. This one I was fairly content with. I think the fact that I wrote as 2.6 squared isn't a reason. They wrote as 3.6 squared. Why shouldn't I be able to write that? So I'm going to give myself all the marks on that one. Now, part D, this number is too big. Yeah, I should have got 25.4. So I'm out by orders of magnitude. But why? 0.0153 points. Oh! Right, so here's the trick. I've done this. My dVdt is in centimeters cubed per hour. This, my dHdV, or the dV by dH, right? This is, of course, because y is in meters, this is in meters cubed because y is in meters. So when I differentiate dV by dH, that is in meters squared. So this is wrong. So either I wanted this in meters cubed, so that in meters squared should be 3. So if I wanted that in centimeters squared, there would be an extra 2 zeros in it, and then I would pick up the decimal place where I needed it, right? Because that is in meters squared. Because of course, volume is in meters cubed, H is in meters. So the whole thing's in meters squared. That's why that number came out so big. I was certain there was no way that pool was filling that fast. That felt insane. Ah. So I wanted that in centimeters squared, and then I would have got the 25.44. Right, so where do I lose the marks on that one? I mean, let's go look, because I think, do I get the method mark for the chain rule at least for part D? So I get M1 for finding dVdH or attempts to, so I will get 1 mark from that. Okay. Must reach a value for dHdt, but do not using the chain rule. So actually, I don't think I lose too many. Actually, it's just, I get quite lucky on that one, I think. So it's just the answer mark I lose out on if we look at this down here. Right, if we look down here, I get M1 for recognizing that that's needed and use it from their integration. Must be clearly identified, which it is. Correct use of the chain rule, which I did. Ignore any confusion with units. I only lose 1 mark. So interesting. I would have thought that was the question where I would have lost a lot of marks. And that's it. So let's add this up. 10, 19, 28, 36. Oh, 36 plus 8 is 44. It's 50. 58. 58, 65. 65. Yeah. 65. Is that it? Out of, what's it out of? 65 out of 75. Okay. Not perfect. It's definitely not 87%. And we did it in 90. Well, I did it in, so how long would I have had left? So on the clock, because that was our metric, right? We had, so on the clock, I've got 10 minutes left, but I'd set the clock for an hour. So we had 40 minutes left. So we're going to do 87 times by 40. It's 86.7%. All right, let's do this properly. Which is 3466.7. Score. Interesting. What did we get on the other one? What did we get on the other one? Hang on a minute. You can probably tell me. 460. So it is definitely better. So I'd got 92% on the previous paper. So I've dropped a few percent, but I did do it a lot faster. Happy with that. All right. So if you found this interesting, drop your email in a link underneath and we will send you this PDF, warts and all, with my working on it. You know, for better, for worse. It is what it is. Hopefully you found it interesting. Hopefully you found it interesting. Let's change this to a green so we can see that that's what that is. And yeah, if you are finding these useful or vaguely entertaining, do let us know so I know whether or not to keep doing them. And in the meantime, I will see you all soon for another Nick attempts to do a paper really good without making too many mistakes. See you soon.